class, dimensions are your
Friends.
You are going to have a lot of friends in this class. We don't have that many yet, but in the end, you're going to have a whole bunch. And you're going to want to keep track of those friends. The way we're going to keep track of our friends is via our table of friends. Today, we're going to start our table of friends. And you are going to continue this table of friends until the end of this class in May or June, whenever that does occur. So you want to have a table of friends, maybe next to the boxed equation page or something like that, but this is something you need to keep track of. So here we go. There are going to be various columns. There's going to be a name column, a symbol column, units, and equations. Today we're going to be adding 5 different friends to our table of friends. John, we're going to add 1 friend. So tell me anything we've learned so far in the class.
Velocity.
Velocity is the 4th of the friends, so I'll put it down here, velocity. Now we need to fill stuff in. We need symbol, dimensions, and equations. We can also add other friends. Eileen. You could name something else we've worked with already, or you could fill in for velocity.
Acceleration.
Acceleration is the last one. That's the one at the bottom. More stuff, please. Anthony. Position actually is not going to be up here. We are going to have position, but it's not one of the original names. It's going to be involved. Check. Displacement is going to be involved in the displacement, so we're going to have, that's the second one, displacement. Again, we could be filling to the right, or however you would like to do so. Yash? Anything else there? Time? Time, again, is included in here. Time is universal. It's in all sorts of different ones. Erica?
The symbol for displacement is delta x.
Delta x, the change in position. So that's where position is. The delta x, the symbol for displacement. Sean?
Displacement, equation is delta x final, or yeah, delta x equals delta x or no, it's time.
No, that's, displacement doesn't have time in it. So displacement, the delta x is equal to,
The change in position.
right, that's what it means, but
Yeah.
mathematically.
So it's the change in position for the final minus change in position.
Ah, it's just the position, right? The delta means the changes, so it's just position final minus position initial, not delta. Kier?
The equation for velocity is the change in x over the change in t.
The change in position or the displacement over change in time. Good. More stuff, please. Ben?
Dimensions.
So we could give the units, the dimensions for anything? Yes? Like you could tell me what the dimensions are for displacement, for velocity, acceleration.
Meters over seconds.
For what? For velocity. So the dimensions for velocity are meters per second. We could, of course, have other things, but in base SI dimensions, that's what it would be. Laura, add something?
Displacement meters.
Again, it's linear, so base would be meters, but we could have all sorts of other things on it.
Speed.
Speed is going to be the 4th one here.
And also what numbers are velocity and acceleration and the rest.
What number is velocity? So these are, we have the first one to yet to do, but these are everything except for the 1. We're missing 1. Luke?
Speed in meters per second.
It's also in meters per second, just like velocity. Good? Here?
The equation for acceleration is velocity over time. The change in velocity over time.
Ah, important, that change in, the delta V. So change in velocity over change in time. More stuff, please, Thomas?
Units for acceleration are meters per second squared.
Good. Lauren?
I have a question.
Yeah.
You don't put the direction as a unit that is not included?
Direction, we haven't quite figured out how to do the symbol for a direction. We'll do that actually when we get to chapter 3. We'll add some stuff to the table of friends. It'll, yeah, we'll get there.
I'm not asking what the symbol for velocity is a V.
Symbol for velocity is a V. Ballerina.
The equation for speed is distance over well, change in x.
The equation for speed is not distance over time. Sean, this is not an equation. This is just distance over time. So often we miss major, yes? Yeah,
It's
that's velocity. That's okay. Hey, often I get this for equations, and students somehow miss a very important part of an equation, which is the equal sign, right? So it starts with what is equal to distance over time? Speed. Okay. It's a little thing, but unfortunately not in the long run, because so often people just ignore that equal sign and it just becomes a random string of numbers. Okay, so we need the dimension or the symbol for speed, and we need to know what the other thing is. Who's got one of them for me? Houston.
Speed is s.
Usually we use a lowercase s for speed. Oh, actually we need the symbol for acceleration as well. Emily?
Lowercase a.
For acceleration, notice an uppercase A is something entirely different. We'll get there in a little bit. Chloe.
Is the first one distance?
It is not distance. Distance is just, well, distance isn't really on here. There's various things that we don't actually end up putting on here. One more. Something else we've talked about in this class that's important enough that we're going to use throughout the course of the entire year. Houston.
Magnitude.
Magnitude. No, that would be a part of something called a vector. We'll get there in a little bit. Here.
Is it relative error?
Relative error. Relative error. We need a symbol, a dimension, and an equation. Jimmy, one of any of those.
The equation is relative error equals observed minus accepted over accepted times 100.
Thank you for making an equation. Yes, Chet.
The symbol is uppercase E and subscript R.
Good. Last one, the dimensions for relative error, please. Prescott.
Percent.
It is in a percent. Good.